is basically a tool for orchestration, okay, of large language models. But there are many, many other large language models, as you've heard probably, right?
Yeah.
So there are like many, many different models, and these are the main, let's say, flagship models. And then there's, I don't know, so many other models on top of those models. Yeah, you can find models with respect to anything, right? Multimodal, so multimodal models, computer vision models, natural language processing models, audio models, tabular models, etc., etc. So there are many, 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 many models that that are built, okay, basically every day, that are shared through, let's say, platforms like Hugging Face that people can use, that focus on a very, very specific kind of like problem. And the issue that we're having a little bit is that, right, every time a new model comes up, or every time like even within the same, let's say, company, right? If you look at OpenAI, every 6 months, the syntax changes completely, right? So there's usually a legacy syntax, and there's then the kind of like, the new version of the syntax. And when you are running LLM applications, then this makes it very, very hard actually to to then kind of like stay, let's say, in sync with the most recent developments. Okay, and what Langchain does basically, it abstracts away, or it provides kind of like a layer between us and whatever large language model you're using, by creating, let's say, standardized functions, okay, that where it basically doesn't matter what model you're using, you can use any model, and you're basically, the front end code of your application remains the same. It's kind of like written in the, let's say, Python based syntax of Langchain, okay, and then you can then add or attach to it any large language model that you like, whether it's one of the big providers that you've mentioned, or whether it's some smaller model from Hugging Face. And I think this makes it really powerful, because, as you know, you need to decide. So when you think about taking or using an LLM model, you need to there are the great models, like everyone is talking about. Okay, now this is now we have, I don't know, Claude, Opus 4. Now it's the best model in the world. But the question is, like, do you need the best model in the world to, I don't know, for example, extract information from an invoice, right? So cost is an important factor, and I think the costs have gone up significantly, for sure, for the OpenAI GPT 4.5 model, right? The new one, I think costs have risen a great time. And I think Opus is also relatively expensive. I think it's one of the most expensive, or if not the most expensive model out there in the world. So you basically, doesn't make sense to use it for like easier tasks where you could use a simpler model at lower cost. So cost is a big issue, and then also speed, right? So the big models, those reasoning models, as we say, right, they need a lot of time, right? They because they first basically analyze the query, then they plan out how they want to tackle, kind of like, to create an answer to that query, and then they build it out kind of like step by step. So this takes time, this produces costs, and yeah, and so it doesn't make too much sense to use the best model all the time, right? So I think there's a lot of value to gain to try out smaller models and see, like, what is the, let's say, least sophisticated model that I can use for my task that still works reliably well, right? So this is kind of like what we are looking for. And then Langchain as said, provides the orchestration for you know, for doing that. Okay. I think it was found this soup, like it's brand new. So we're still in the V0.2, now V0.3 version. So it's really kind of like new. Yeah, probably 2 years old or so. But it's really developing very quickly, right? So as said, we can use it for, you know, we can use it for building chatbots that incorporate memory, no matter what basically LLM is behind it. We can use it to build agents. We're going to discuss this in a moment, what the kind of like agents is. We can use it for RAG, what you've did. We can use it for kind of like Q&A, summarization, and then using it with kind of like graph databases as well. So knowledge databases where you are able to where you basically allow the model to use kind of like internal information, use kind of like you know, the files that you have, you know, to provide a more accurate and context-specific answer, let's say, right? So this is what I would like to jump into, because I do think that this is really you know, this is really kind of like one major driver of LLM application development, yeah, because it makes orchestration so easy. Okay, and this is what I want to demonstrate to you. The ecosystem of Langchain also has two like other programs. There's LangGraph, okay, specifically for basically orchestrating agents, so LLM agents versus LLM, let's say, workflows, as we will see. And then there is also Langsmith, and Langsmith basically is about monitoring your LLM application. So it's basically here all of the logging information is you know, analyzed in real time, and then you are informed about, you know, how, like, what's the speed of your models, are there any, let's say, latency issues, any things that need further debugging, etc., etc. So this is what they've been able to kind of like build out kind of like so far. Yeah, so basically, this is, I mean, generally what I would recommend to you that you kind of like have, I mean, definitely have a look into the documentation of you know, of Langchain. Although we will, you know, we'll work on a few examples here. Okay, great. So I mentioned, I think, a lot of words, probably Tobias as well, and there's a lot of debate about you know, AI, and probably the buzzword of last year as well as also this year is basically agents. You probably heard about that. What are agents? And I think Anthropic came up with a very I think nice definition of what agents are and what agents are not. Okay, so then they basically split up, let's say, the use of LLMs either within so-called workflows, okay, where LLMs and tools are orchestrated through predefined code paths, okay, and agents, which on the other hand are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish their tasks, right? So basically, this is all predefined, basically coded by the human, and this is, let's say, more dynamic, right? Where basically the LLM either partly or fully decides how to accomplish the task. Okay. Good. And right, so here are some of those, you know, frameworks that one can use to set up agentic system, and I already shown you LangGraph from Langchain is one. But please note that there are also Amazon Bedrock has, you know, is also an AI agentic framework. There's also Rivet and there's Velum. Okay, but let's take a look first of all what how an agentic workflow looks like, right? So basically, we have kind of like the input, okay, into an LLM, right? And then basically the idea is, okay, in order to to solve that question or input that we are getting, the LLM either needs to query results from some database, which we call retrieval, or use some tool that we provide to the LLM, or to be context specific, it should have the ability to read and write memory, like information from the memory. So basically, like it could be information from the conversation with the user, yeah, to create the output, yeah. So if we're talking about prompt chaining, basically, the idea is, right, everything is predefined, everything is kind of like coded out. So for example, if you get an input, you do the first LLM call, then you get basically an output, which, for example, which could be a function, which then lets you know, okay, have you been able to solve it or not, right? This is a little bit like the chatbots work. And if you are not able to solve it, then you exit. But if you pass it, then you can maybe start with the next call and another call until you get the kind of like the output, right? So this would be more an example of a prompt chaining workflow that one can build out for an LLM application, which would not be agentic, right? Although like free LLM calls are included in here, right? According to this definition, yeah, this wouldn't be an agent. This would be a workflow, basically, right? This would be an agentic workflow, but not an agent, yeah. Right. So this is basically idea for a situation where the task can be easily and cleanly decomposed into fixed subtasks, right? So this would be something like an example, like, I don't know, I want to extract information from an invoice, right? And if it is really an invoice, then we basically proceed to somehow, for example, pre-classify the information there to go into the accounting system, to go into our, let's say, payment scheduler, etc., etc. But if the first call, for example, decides that, okay, no, this is not an invoice, this is some other document that basically entered the system that, for example, it does exit, yeah. So this is what we basically call gate. There are also workflows around, let's say, a router. Okay, so probably you heard about that. So router is basically when you get the input, the LLM decides what call to use next, right? So whether it should be call number 1 or call number 2 or call number 3, right? Or it could also be, right? So yeah, so basically it's kind of like classifies, like the call router classifies the query from the user to then, use the most appropriate next LLM call in the chain. Yeah. Another way to do this is basically where you get the input and you parallelize kind of like the input into let's say 3 calls. So this is where basically, I don't know, maybe the input has 3 different aspects to it or 3 different questions. And then basically each LLM call focuses on one of the subtasks in parallel, okay, to, for example, speed up the process or also to be more focused on the specific subtask that you are dealing with. And then there's an aggregator that puts it all together and then returns the information back to the user. Yeah. So this is also kind of like where potentially for each of those different subtasks in parallel, it would make sense to use a different LLM provider. Right? Maybe for one, Llama is good. For the other one, we need Claude Opus 4. And then there's another one, we simply use a standard model like OpenAI GPT 4.1, okay, which is kind of like now the most recommended LLM model to use by OpenAI. Yeah. What else, right? We can again, put this all together into also an orchestrator workers workflow. Okay, so we have an orchestrator at the beginning that decides, okay, do we need all of those 3 cores, or do we need just one? Do we need 2? And then we have the different like specific LLM cores that work on the designated task, and then we have a synthesizer worker that basically combines it all together and then delivers the output, right? So there are many kind of like things that we can do. One of the most sophisticated is maybe, for example, this one here, where basically you have an LLM call kind of like generator after the input, and then after that you have an LLM call evaluator, okay, that either accepts the information that the LLM call generator has provided, or if it's not satisfied, it can send it back to the LLM call generator to be kind of like refined. So I think this is a lot what you see. I don't know whether you've used one of the more modern agentic, let's say, workflow IDEs like Cursor and Windsurf. Have you heard about that? Tools, Federico or Igor? No?
I don't think so, no.
Okay, so this is, I think, also something that we should focus on. So what is the main IDE that you're using kind of like so far? Are you using just Jupyter notebooks, or do you like to use Visual Studio Code, or what is your preferred IDE?
Visual Studio Code.
Okay, great. The Copilot in there, do you use this a lot or a little bit?
No, without Copilot.
Without Copilot so far. Okay.
Yeah, I've tried it with, and it's like sometimes it's quite okay. Like the filling of the code, I like, like how it will tell you, like give you tips on what your next part might be, which helps like a lot. I feel like in the beginning parts when you're loading, pre-processing, all of that kind of stuff, I think it's pretty good at being able to tell what your next step might be.
Yeah.
And also, to give you some tips, like once in a while also it's been like, oh yeah, right, I forgot about that. Okay, I should add that also and stuff, So yeah, but I think it definitely needs still some improvements. I guess it's not, but yeah, it's.
I think this is probably the most dynamic field so far. So I think this one started it. Cursor, the AI editor. Okay, I'm just going to show you and then maybe demonstrate it to you tomorrow, right? So this is a fork of VS Code, of Visual Studio Code, right? So because VS Code, right? Belongs to Microsoft, but it's pretty much kind of like an open source program, right? Because you can use it kind of like for free, right? And it's also available in GitHub. Okay, so what these guys did here, they have forked Visual Studio Code, okay? And what they've added is, kind of like a chatbot into the Visual Studio Code application, okay? And the same these people did as well, right? So you see, I think here you can see it quite nicely. And then you have like a chat interface next to it, okay? And the chat interface pretty much works like it's shown here, right? So for example, I could write, write me a script to, to download or to scrape information from kind of like a website. So the tool will, is able to access your code base, to access your files, and to write the code into the file, okay? And then they've put a lot of effort into an LLM call evaluator. So then there's another LLM call, basically. I don't know whether we can see it here, right? And then the evaluator checks what has been, so to speak, done. Okay, and then if the evaluator is not satisfied, and we can see the conversation here on the right hand side, yeah, then it will go back to the generator and then asks asks it to do more, to basically to refine the code, to make it better, to to make sure that all of the input requests have been satisfied. Basically to solve out, let's say, the most obvious errors, right? Like you said, Friederike, sometimes it works good, but often you need this forth and back, yeah, in order to make it work good. And so what these two basically companies have done, they have worked a lot on this, basically on this evaluator optimizer to sort out, let's say, the most obvious issues, okay? And then this makes it quite powerful, because at least for, let's say, subcomponents that are relatively straightforward, it can pretty much code them out without error, right? And then this doesn't happen, in line only, but it happens over the entire, let's say, code base, over the entire, for example, Python script that you are working on, until it's resolved, and only then you get the output, right? And so, yeah, and so I think this is kind of like what made this kind of like more powerful, right? So basically, like you can see here, let me check if there are any other integration test files that need documentation by searching in the integration directory, right? So here basically someone asks, okay, I've got my code base, and now please create for me like a documentation for the code base. And then basically it can go through all of the files and then create a document, and then you've got the evaluator to continue to ask for more until the evaluator is satisfied. Let's say for kind of like a governance of your LLM. So for example, when for some reason your LLM call generates a solution that is inappropriate, you could also block it by the call evaluator, right? So you can say, for example, I don't know, if it's like a chatbot talking to your customers, right, the evaluator could, for example, check whether like there's no internal information going out, right, or no inappropriate information going out, right, or accurateness, like you said, right? So we can maybe give the call evaluator the possibility also to, I don't know, access the web and then evaluate whether this information that was generated by the call generator, whether it's accurate or not, and if not, block it and reject it back. Yeah, so a lot of safety measures can be built around this evaluator. Yeah, very good point. Yeah. Good. Now let's move to kind of like the agents, because when you listen to that, then or basically when you like when you kind of like see that, a lot of people say, oh, that's an agent. The call generator is an agent, and the call evaluator is an agent. But I think we need a more strict definition of what really an agent is, and so the way how Anthropic basically thinks about an autonomous agent is the following. Right, so a lot of things has to do with how sophisticated kind of like are the tasks, and do they use tools, like does the LML call use tools that interacts with the environment a little bit, right? And so this is, I think, probably more than specific to your, let's say, what you were talking about, Friederike, right? Like a fact checking or something, right? There's a human, there's an LLM call, basically going forth and back, and then the LLM call, can enter the environment and then get information from the kind of like environment, and then decides autonomously, so to speak, to either continue the, conversation with the human or to stop it, right? Yeah, so the nice thing about this, basically, that this kind of like architecture can be used for open-ended problems, right? Where it's difficult or impossible to predict the required number of steps, and where you can't hard code a fixed path, right? So this is this is more for when we for kind of like the unknowns, right? For handling that, as you give the LLM call, access to whatever environment, and basically to put this into equation and to decide for how long it's going to be, for example, interacting with the human, and when it's going to kind of like stop it, right? So here we have kind of like the high level flow of the coding agent, right? A human query where maybe the tasks are, I don't know, not clear yet. So for example, an agent would then go back and kind of like ask the human to clarify exactly what they need, right? So you first of all see here refine, clarify, kind of like a conversation around that, okay? Before just going and starting off with the tasks. So this makes it very flexible, and then once it's clear about what to basically do, so once the, so to speak, the context is clear, then it goes out to the environment. For example, it searches files and basically returns information, or it writes code, or it does test functions, etc., until it's kind of like complete, and then through the interface, then the information is displayed back to the human, right? So basically, right here, so here the workflow, let's say, is a little bit like it's less defined, right? You simply give the LLM tools, and then let the LLM decide by themselves what to use specifically, right? Where basically in the process here, we basically told it, okay, you only have the possibility to go to do 1, 2, or 3, or one of those, or all of these together, yeah. That's basically it. I will share this document nevertheless to you. I think it's an interesting read. Everyone basically is referring to this document as was kind of like the first to be kind of like cited. Okay, good. Then let me just stop for a second here.
Noted.
I think they should be able. I think it's here
Yeah,
anyway.
it's there.
Okay.
Yeah. So everything that's also in the session should is going to be displayed. So you see the link here, and you see the zip file. Okay, so if you could download that, it would be great. And then you put it into a folder, and then it would be important that you that in the folder that you're working, that you put in your environmental variable. Okay. So for example, with your so this is, for example, my IDE. Okay, and here basically I've created a new file, and then I called it .env, and basically what you can see, this is a file that when you deploy your application, for example, or when you basically when you deploy your application, or when you push it to GitHub or some other, let's say, version control system, then this file is ignored, because what does this file include? It's my OpenAI API key, right? So if this would be exposed to other people, and sometimes you read that, okay, there's some security, whatever issues, then it's often because the .env file has been somehow exposed, or sometimes the information is called in the it's also written in the config.py file as well. It's basically all of your access key, access information, your SSH keys, your API keys to your backend, to your frontend, etc. It's kind of like standard practice to to put this into such a file, and then basically from the Jupyter Notebook, you can access the file, right? Without the file being, let's say, exposed in the Jupyter Notebook, right? So
Yeah.
basically, as you can see here, we are accessing the Open API key, by running like the environment get comment, and the environment get comment looks out for this .env file and looks out for this OpenAI API key, and it does find it here, and then it assesses it and basically brings it back to the Jupyter Notebook, right? The alternative to that would be, if you don't have the .env file, and this is maybe quicker now, you could just, in the Jupyter Notebook that I provided to you, you could simply copy your OpenAI API key basically into here, yeah, and then you have it. Or basically you're not searching it, but basically your OpenAI API key, you are basically putting it like you are gonna put it in here, okay?
Yeah.
Rather than searching it. Yeah, so this is just a way, because, for example, I want to share with you the Jupyter notebooks, but I don't want you necessarily, although of course I would trust you, right? I don't want you necessarily to have my OpenAI API key and then use it by yourself, share it with the world, etc. And this is how we go around it.
Yeah. Okay. Thank you.
Okay.
Yes.
Good. So let's. Okay, so let's kind of like, let's start with Langchain, okay? First with models, prompt, and let's say output parsers that we can use, yeah? So basically here, I want to introduce you to how we do direct API calls to OpenAI through Langchain. And then basically how we use some of the orchestration tools that are available, such as prompts, models, and output parsers, right? The first thing you need to install, in case you have not installed it, would be your Python.f. This is basically to find the environmental kind of like variable, and then here OpenAI. Okay, because we want to first use OpenAI as like the normal way, and then we want to basically try to use Langchain instead of it, right? So here we're starting off with just the regular workflow of OpenAI, so yeah, this is basically all installed, and then let's see, we can double check whether the Open API key has been loaded successfully by running this function here, and here basically did find my environmental variable. You can even see, right? I mean, it's not visible here, right? So you can even the Jupyter notebook here, it's not visible, but it's there. It's in the folder, okay? And because it's in the folder, but even here, like in my Finder, you don't see it, right? So it's basically, it's really hidden for everyone, okay? Only in the real IDE you can see it. Yeah, it's kind of like a little bit. It's hard to see, but it's a little bit darker sometimes shown, like in a little bit gray. Here it doesn't show that perfectly. Maybe if I change my theme a little bit, maybe. Yeah, so this is like more black and this is a little bit gray. Maybe you can see this better. And then this is why it's only shown in an IDE system. Yeah. Okay, good. And then we can decide what model we can use. Like we can put into the LLM object GPT 4.1. So it seems like, I mean, the documentation that we have like 4.5, now we have also 4.1, and for like as a standard model, they recommend use GPT 4.1. I think it's a little bit cheaper than 4.0, okay, and it does have most of the functionalities. Okay, yeah, so let's start with a direct API call to OpenAI, right? The standard way to do this is we write a get completion function with a prompt that we can then specify the model that we want to use. We've specified the model here, but we could have also directly written it here, but of course it's not that efficient, right? Because we want to change the model, we can do it up here, and then basically the entire code base then doesn't need to be kind of like changed. The client is OpenAI.openai. message role user, and then content is the prompt. Okay, and then the response that is generated should be generated through chat completions create. That's basically telling the OpenAI API that yeah, we want to chat with it. Okay, and it should create an answer. And then yeah, basically the model to be used should be the model up here, which is the LLM model, which is the model that we specified up here, right? Then we have kind of like the messages that will be kind of like get in there as a kind of like as an and the maximum would be 1 here, right? There are models, I think Gemini has 0 to 2 or something, right? So even there we have like kind of like differences in the possible parameters. Yeah, and then we want to return the most, let's say, recent answer to what the model has created. Okay, good. So we'll run that, and then we can so we have created this function. Now we can say get completion. What is 1 plus 1? Let's see, and then we get the result 1 plus 1 is equal to 2. Okay. Now let's deal with something else. Let's deal with now a customer email that we get, and so this is a little bit. So this is a customer email, which was written as the Americans like to say, pirate English. Okay, so pirate English is a little bit like, I be fuming that me blender lid flew off and splattered me kitchen walls with smoothie, and to make matters worse, the warranty don't cover the cost of cleaning up me kitchen. I need your help right now, Mate. So it's a little bit kind of like slang, pirate, whatever, pirate's speech, okay, of like a customer. Okay, so we put this in as a, like, it could be coming from a customer email or from a chatbot or from Slack or whatever. And then we create an object. Another object, we call it style. Okay, and here basically we say, okay, American English in a calm and respectful tone. Okay, so this is something like potentially this is hard to understand, right? So we maybe need to first, let's say, transform what was kind of like what we got as an input from the customer into something that our employees, our customer service people are able to deal with, because this is a little bit difficult to deal with. Okay, so it's like potentially as a non-native English speaker. Yeah, good. Now, so we want to transform it into American English in a calm and respectful tone. Okay, good. So now we're gonna formulate our prompt. Okay, and our prompt looks as follows. So we put it in as a string, basically, right? So translate the text that is delimited by triple backsticks. This is basically this one here. Okay, it's just to to make it look nicer in a Jupyter notebook, so that it doesn't, so that's not presented in one line. Otherwise, I would need to scroll forth and back all the time. So this is why it has those triple backticks. But it, of course, the sentence doesn't stop here, but goes on into the next line. Yeah.
Yeah.
Okay. Into a style that is, and then style, we basically put in the object that we've created here. And the text that goes as an input is then the customer email, okay, from above here. Okay, so this is how you could, for example, work out, let's say, a prompt that is a little bit, let's say, more universal, right? In that, yeah, you basically, here you have placeholders, yeah, for customer email and for style, and then you can change the style and or the like a different customer email above here. Okay.
Yeah.
Good. So we do this, create those customer email, create the style. Now we print the prompt. Now you can see the placeholders here. Now they've been now they are now including, if we print the prompt with translated into style that is American English in a calm and respectful tone, right? So it did fill out this placeholder. And then the customer email here, Okay, it's the email down here, text, and then there comes RRB fuming, that my Blender lid flew off, blah, 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 yeah? So basically, there's a way to combine it, let's say, kind of like a little bit best practice way. Otherwise, you would need to like change the prompt all the time or copy and paste the customer email in there all the time. It doesn't make sense. It makes sense to abstract it away and to create designated objects that you can then fill into these placeholders here. Good. Now we can send this prompt into our get completion function and store it as a response, and then we can now show see the response. Okay, now they have translated from pirate English to friendly, calm English, and then it's written like this: I'm quite upset that the lid of my blender came off and splintered smoothie all over my kitchen walls. To make matters worse, the warranty doesn't cover the cost of cleaning up my kitchen. I would really appreciate your help with the situation. Okay, now, okay, we can have a normal customer agents to deal with this request.
Yeah.
Okay. So this is like a way of how you could do this with, let's say, with kind of like OpenAI. Okay. But now let's move on to to Langchain. Okay. So how we would do this differently in Langchain to basically demonstrate the point of how it could be achieved maybe a little bit more, let's say, even more modular, even more like flexible, and potentially even with a little bit less code. Okay, so chat API for Langchain. The first thing we need to do is pip install or upgrade Langchain and Langchain community. So there are different libraries for Langchain. Show you this real quick. Langsmith. Glossary. Yeah, so basically we have Langchain. Yeah, so here we can see. Yeah, so we have Langchain core, we have Langchain, we have Langchain community edition, we have Langgraph, and there's also Langchain experimental for everything that is let's say for research and experimental users, where they basically see or say you can use it, but be careful. We're not guaranteeing that things work out here perfectly all the time, right? And yeah, so we've got the Langchain core with Langchain OpenAI, Langchain community, where basically people can generate their own functions and send it out to the world, and we can use the function of someone else. So it works a little bit like, let's say, like general Python, Python libraries, right? Where you basically use, pandas, and then you've got pandas community where other people wrote some pandas functions, and then you can basically use it. Yeah. But these are the most important, I would say. Yeah, experimental community, and then the core, and then specific designated ones, like specifically for OpenAI, right? Okay, let's go back to my IDE. So we do that. We're going to upgrade this. It's already done. And now we can, from Langchain.chat models, we can import chat OpenAI. We could import also other Anthropic or Gemini or whatever, right? So it's all in there. So it makes things already kind of like very relatively easy. And then we can basically create our function. We're going to call it chat, okay, and we're going to use the chat OpenAI function from this chat models library here, and we're going to set the temperature again to 0, and the model to the LLM model once again, so that we use the same model as you've seen up here, right? The GPT 4.1 model, yeah. Where is it? Yeah, so it's here basically now. Okay, now we get kind of like, yeah, the confirmation here, basically the API key that was found, etc., etc. Okay. Now, what we can do is now prompt a template for our, let's say, customer service chat. Okay, as follows. So first, we create an object we call a template string. So which says translate the text that is stimulated by triple backsticks into a style that is this and that, right? So this is basically, this was our prompt before, right? This was the prompt that we've used here, right? So basically here we use it as a direct prompt, and here we are in Langchain, we're not calling it prompt, but it's basically the prompt, but we call it a template string. Okay, now this is formulated here. Right, as you can see, still there are these placeholders in there, style and text. Okay, and now we're going to import from Langchain prompts the chat prompt template. Okay, and the chat prompt template, in other words, helps us to create Langchain functions to basically achieve, like, Langchain functions to basically execute the task that we just have did, namely to take a text in a different language. In this case, it's Pirates, American language, and put it into American proper English, basically, right? And the way we are doing this is we after we've imported this library, we basically from this library we use the from template function, and we put in there the template string. Okay, from here, run the template string, and we put this into this chat prompt template generator, let's say. Okay, and then when we basically show how the prompt looks like, we can see that basically this has created a function. Okay, it's called the prompt template function. And the function looks like this. It has two input variables. One is style and one is text, right? So basically out of this prompt that we've generated here, the template generator has been able to create a function that needs two inputs. One is the style and the other one is the text. Okay, there are also some other things that we can specify, and then the template says translate the text that is stimulated by triple backticks into a style that is style, etc. Good. So we can also ask for the specific input variables, and for any, let's say, chat prompt template that you've generated, and like to learn what your input should be. So the input should be style and then text as before, right? So now we can generate the style, American English in a calm and respectful tone, and we can generate the text. Okay, and now this is how we can, so to speak, put it all together and execute this this chatbot function, let's say. Okay, good. So we put this into an object that will later print, but basically we say customer messages, create customer messages as follow. Use my prompt template, okay, and then format messages is kind of like the designated function that should be used, and the input to that function should be first the style, the customer style, and then later on the text, and this will be the customer email. Okay, and when we do that and then print the customer message, we do see, okay, first of all, the type that this is a list, and then we can then print the most recent kind of like message, and then basically here we see all of the information, right? So we do see what is basically been inputted into the customer messages. So we can see first the content, translate that it should be translated to American English, then the text that is kind of like injected. And so basically now this customer message here is ready to run using our chat function. And then if we print it out, then we get the answer. I'm really frustrated that my blender lit off and splattered smoothie all over my kitchen walls. To make matters worse, the warranty doesn't cover the cost of cleaning my kitchen. I could really use some help right now, right? So this would be the alternative way, right? So basically, as you can see, it's a little bit, it's like in this case, it's more modular. We're creating these standardized functions that then are looking out for input variables. Okay, and then when we execute our chat function, right? Basically from here, then the response is generated, and yeah, now we have, once we've created that, we can basically always use this format messages or this prompt template, to generate, let's say, like to generate like in a kind of like a very standardized ways answers for our customer. Basically, the strength is a little bit then how you then kind of like combine it into, let's say, a new function. So you basically create your tailor-made functions, where basically you don't like, you can maybe where here basically it's hard to mess around with the prompt, right? Because everything is inside the prompt template, and then you are only dealing with kind of like the input variables, right? So it makes it, I think, a little bit, let's say, a little bit more modular, it feels, yeah. Although I do agree, right? I mean, potentially, potentially, I don't know, you could, I mean, this is still not a bad way using those objects here, right? I mean, this is a little bit of workaround. The best thing basically you can do, like the same function that we could use through Langchain. But let's continue a little bit. Let's see whether we can basically kind of like continue with I don't know, maybe we get we now want to work on, let's say, on a response to the request of the customer. Okay, and our service agent says, okay, hey, their customer, the warranty does not cover cleaning expenses for your kitchen because it's your fault that you misused your blender by forgetting to put the lid on before starting the blender. Tough luck, see ya. Okay. So the customer is a little bit, yeah, that's a little stupid customer. He's not that friendly, but it's still written in, like, let's say in American English. But maybe we want to talk back to the customer in their language, which is the pirate language. Okay. So, and we maybe want to do it also a little bit more polite, because this is not very polite. Okay. So we want to do it polite, but also speaking in English pirate. Okay, so we put in like a service reply, and then a service style in pirate style. Okay, good. And now we can use our prompt template that we created before. Okay, and we simply put in style, the service style pirate. The text would be the service supply, and then we execute that and then print it out. And then we get the following answer, like, ahoy, valued customer. I be sorry to inform you that the warranty be not covering the cost of your cleaning year galley, as the mishap with your blended forgetting to secure the lid for yet set sail with it be considered a matter of misuse. Regrettably, this be outside the scope of the warranty. I be having another, if you have another question, don't hesitate to send me a message in a bottle. fair winds to yeah. Okay. So yeah, so I think now, as you can see, now we progress, but we don't need to write kind of like the prompt again, basically, but we use our template, and then we just need the input, the service supply, and then the pirate, and then basically the prompt is inside this prompt template, like in the prompt template, and now we can, we can now work, like basically build out a system for, for any case that we're dealing with, be it like a French customer, German customer, being it more friendly, less friendly, or whatever, right? So I think this is where basically you then abstract away a lot of kind of like the problems under the hood, and then you're just dealing with the answers and the style. Yeah.
The weird thing is, like, to me, this could also be Northern Irish, except for like taking out the ahoy and the aye parts.
Yes,
it's basically Northern Irish as well. So
maybe
I wonder, like, where
they were all the pirates back in the days.
Yeah,
right?
probably. But yeah, it's weird to me that the system can also, like, that the model can actually understand those small nuances, kind of. Yeah.
Right. Yeah.
Yeah.
Yeah, because I mean we're using 4.1. I mean, this is still a good model.
Yeah.
But yeah, but we can then tweak around and see whether can we use a cheaper model, like a cheaper model, or can we train it, like fine tuning, like basically Tobias told you, to make it even better, even funnier, or whatever. Yeah, but this is how we can use Langchain here, okay, in a prompt. Now, let's now also talk about how we would like the LLM output to look like, okay? Because often we don't just want text, okay, but maybe we want a dictionary style, JSON style format that we can put into our database, etc., right? So let's assume, right, this is like this is a dictionary, right? We've got 3 keys: give, delivery days, and price value, and we have values false, and then like so now we put in, first of all, 2, let's say, objects. One is a customer review, and the other one is a review template. Now the customer review looks like this. This leaf blower is pretty amazing. It has 4 settings: candle blower, gentle breeze, windy city, and tornado. It arrived in 2 days, just in time for my wife's anniversary present. I think my wife liked it so much, she was speechless. So far, I've been the only one using it. I've been using it every other morning. It's slightly more expensive than the other leaf blowers out there, but I think it's worth it for the extra features. That's the customer review that we got. Our review template that we've developed inside our agency looks as follows. For the following text, extract the following information. Gift: was the item purchased as a gift for someone else? Answer true if yes, false if not, or unknown. Delivery days: how many days did it take for the product to arrive? If this information is not found, output -1. And then the price value: extract any sentences about the value or price and output them as a comma-separated Python list. Format the output as JSON with the following keys: gift, delivery days, and price value, and then the text that's going to be, then we put it in the placeholder that then would include the text, right? Right. So this is, I think, which really like revolutionizes a lot of things, right? Like in the old days, you had to somehow manually extract the information somehow into a structured format to be able to process it, and now we can use basically unstructured text, right? And then use an LLM to then extract the information from the text in a smart, so to speak, way, dynamic way, right? Now we can go through all of our customer reviews, but we're just starting with one here. Okay, so again, we're going to input our chat prompt template, because we want to create a template, basically, create a designated kind of like function. And the way we are going to create this is, again, chat prompt template dot from template, and then we put in the review template. And this is what we've created up here. The review template is going to be this one. And you already know that the template maker here from Langchain will be able to find the placeholder and then designate the placeholder to be the input variable, right? So we print it out and we see the input variable. There's only one. There's going to be the text as an input, and then the human message will be, or the template will be again for the following text. What you see here, do that and format the output as JSON. Good. Now we can run our prompt template by putting in as a text the customer review that we have from above, right? So basically, this is the review, and basically the prompt should go over this review and then extract the information and put it into a JSON format. So let's see whether this works. So we run it. Okay, so it did extract. Okay, gift is true. I mean, we read it before. It was the gift for the wife. Delivery days was 2 days, was fine. And then the price value, it did find the following information. It's slightly more expensive than the other leaf blowers out there, but I think it's worth it for the extra features, right? This is what got extracted. Now this looks like a JSON, okay, but is it really? If we look into the type of the response .content, we see, oh no, it's a string, right? So while the large language model was able to extract the information and to show it like as if it's a JSON, it's actually not a JSON format yet. It's all string. Okay, so then basically we cannot then use it like, you know, a JSON. We cannot say get me the content for the key gift. It's going to get us an error because it's a string object, and so it doesn't have an attribute. So we cannot basically use it, right? And so this is like a problem that we are running into, that, you know, using large language models, and this is where basically, you know, Langchain was the first basically modules that was kind of like able to help with that issue. Okay, although one has to say a little bit, yeah, one has to say that of course OpenAI, Anthropic, etc., they see that, and then they see, okay, they have developed that, let's develop something like an own function that can also basically as an output deliver true JSON, and in this case they did, but then you would need to use another function that we're using for the API. So the chat model only does text. It cannot provide us with a different format, basically, right? It cannot create a JSON object. Yeah, you would then need to run like another query to change it into a JSON object. Yeah. Yeah, and this is what we want to do with the Langchain parser here a little bit. Okay, good. And for that, we're gonna import from the Langchain output parsers the response schema and the structured output parser, right? So let's say two modules. Okay, and then we can do the following. We can specify the gift schema, the delivery day schema, the price value schema, and then kind of like combine it into a response schema. Okay, so the gift schema will be, we're going to use this response schema method here, basically, with name should be like gift. Description will be what the item purchased, was the item purchased as a gift? Answer true if yes and false if not, right? So basically it's like we are structuring the output that for the key named gift, yeah, it should run this prompt basically, and then whatever is returned will be the value on this key, on the key gift, right? We do the same with delivery days. Again, the prompt, and here it's set description, how many days did it take for the product to arrive? If this information is not found, output -1. The price value, extract any sentences about the value or price and output them as a comma-separated Python list. Okay, so run that. Okay, and now if we response schemas, yes, now we create the output parser. Okay, from the structured output parser, we put in from response schemas the response schemas in there, and now we can look into the format instructions basically that we've kind of like created, and print them out, and then we're gonna get as a JSON what we have basically done, right? So we see already this is like the output will be a JSON format, okay? Basically, we see it here. It's going to be a JSON format with the keys, gift, delivery days, and price value. And then there will be a string returned here, a string here. Yeah, but we can, like, we could also say that it should be, you know, number or whatever. But here we can see the description of what it basically should do. Okay, so let's again look into. Yeah, let's again look into our review template. It's a second template, so it looks as follows. So for the following text, extract the following information. Again, gift, delivery days, price value, and then the text. So this is basically the same prompt as before. Okay. However, what is fed into this prompt is the format instructions using this output parser. Okay, so this is basically put into the prompt. Okay, and when we then create our second review template, okay, which includes those format instructions, these formal ones, and then we execute the prompt with the customer review again. And as format instructions, we use the format instructions that, you know, from above here. So when we do that and we print the message, we can see, okay, it's still the same, let's say, kind of like response. And then down here is the JSON. So here's, yeah, not down is this JSON, so we can see that. Now, as you can see, now the output is a little bit different. So this was the output before, it was string. It wasn't formatted as a JSON object, but now here it's, you know, in this curly brackets as a JSON object here. So we can, yeah, when we run the output parser, we could then see that now the type was changed to dictionary. Okay, and then now we can now ask for, you know, the value of a specific key, delivery days, for example, and we get the response 2 days. And so now we can work with, yeah, with the data, like as a dictionary, because we have, because we have specifically defined the you know, how the output should be parsed, how it should be processed. Good. So this was kind of like this, let's say, kind of like quick introduction into Langchain, and we're already kind of like at the end of today's session. So I want to maybe give you a little bit of an outlook what I would like to do, you know, tomorrow, and then we'll see how much, you know, whether we can finish tomorrow. Maybe tomorrow I think we can probably cover more. So the next one will be Langchain memory. So basically how we can define how much of the previous conversation the chatbot knows. Okay, and there's basically a designated system of you know, of how, you know, of predefining how much of the previous conversation should be used. Okay, and how it should be used, because as probably you ran into the problem that when you're talking, I mean, specifically with Claude, it's the case, but sometimes with OpenAI, at some point it says, please open up a new chat. I am done. Like I'm full, basically, right? Because every time you talk to it, the input is not only your most recent input, but all of the conversation, right? So the longer you talk with the LLM model, the bigger the prompt injection's gonna be, and so the system runs out of memory, right? So it's gonna be even more and more expensive for the system to run. So therefore, those LLM providers, they've built in like safety measures to say, okay, if your like if you basically reach this, like this token size, I'm going to block you. I'm going to exit you out of this kind of like conversation, right? But there's like, there are like smart ways to work around it. So for example, you could, for example, specify only use the last 5, let's say, you know, question and answer, you know, responses that we had with each other, or the last 2 or the last 10. So
Yeah.
so that it's like that it's somehow it has the conversation, but not all of the conversation. But we can also do things like that the previous conversation or that the conversation so far is inputted only as a summary and not the and not all of the details. Okay, so this is what we can also do in Langchain. So this is what we're going to do tomorrow. And then the next thing then would be like kind of like sequential chains. So basically, these are the kind of like this agentic like workflows that we talked about, or basically the workflows, the AI-driven workflows with like a simple sequential chain or like a sequential chain and a router change, right? Right. So basically, where we decide, you know, based upon the input, run this chain or run the other chain. So we can then kind of like work out our own, so let's say, agentic workflow, but not an agent specifically. That's what we want to do. Then I think you did that with like, yeah, so basically this would be like Q&A of a document. So this is a kind of like a designated library for Langchain. So here we are dealing with with like you know, Q&As related to some knowledge base. Okay, and the idea could be, for example, I don't know, to generate product descriptions in a Q&A format, which describes the features of your products in a specific way. Okay, and this could be done automatically by Langchain basically, and then in the end, and then basically creating like summaries or like key features of descriptions, etc., as you can basically see here, right? So there's like Q&A. So it's basically talking to documents and creating a structured output that you can use for whatever, for your website or for your databases, yeah? And then we've got 2 more, then evaluations. This would be like kind of like evaluating the output of your model, okay? Either manually so that you can see it, like did it reason correctly about whether the prompt, did it provide the correct answer? I can either look under the hood how it came to that answer and then identify where maybe it makes mistake, like, or I can do like use it through Langchain and then basically in the end create like let's say like an automatic evaluation. This was the real answer, this was the predicted answer, and was it correct or not, basically. Yeah, so we let the LLM evaluate itself, okay, after creating an answer. This is what we want to do a little bit. And then in the end, there's the topic of agents, where basically you equip your agents with some tools, like, for example, I don't know, access to Wikipedia. Okay, and then when you get an answer, like when you get the prompt, then it uses the tool Wikipedia, but we could give it more tools. We could like give it tools like search the web, for example, or get the stock prices or whatever. And then the agent can then decide what tools to use to answer the question, and we can then look under the hood what it does, and then, yeah, whether it makes basically sense or not.